Okay, think. Hashtag open bar. How about that? Okay, how do you segue to that? I guess you just got to jump right in, okay? So, this lecture is going to be about shoulder muscles. However, before we get into the shoulder, I want to remind you guys from 310 that it's like Batman and Robin. The shoulder and the scapula are a tag team. I mean, they work together. They work independently of each other, but in terms of function, they work together. Remember in 310, I used to do these silly analogies, like if you only move the shoulders, you would be like a T-Rex. The scapula gives you all that extra stuff, okay? So again, in terms of function, they work together, but in terms of their independent function, they are separate things. They have separate muscles that pull on them and influence their motion, okay? So we're going to get to the scapular muscles after, but today's just about shoulder muscles. Specifically, muscles that cross in the front are going to be shoulder flexors, pulling in the direction of flexion. Does that make sense? Anterior crossing muscles are going to pull in a direction of forward. It's not to say they're always going to make your arm go forward, right? Because sometimes they can let your arm go down. Make your arm go up, keep your arm up, let your arm go down, all while going forward. So we're going to have anterior crossing muscles that we're going to call shoulder flexors. Some of them very straight up and down, like a rectus. Some of them come at angles. And it's just the Y component of that pull that's actually pulling above. Okay? We're going to have lateral crossing muscles that we're going to call shoulder abductors. We're going to have kind of medial crossing muscles on the inside, on the bottom part, that are going to be pulling in, adductors. Reminder that abduction, whoever came up with those terms, is probably the devil, because they just sound so close together, right? So we just want to remind ourselves that I say those little silly things, because ab just sounds so close, right? It's just one letter difference. So abductors are going to be on the outside. Now for your circle, because I'm kind of going through this to talk about the class layout of the circle. Anterior muscles, those are going to be our shoulder flexors. Muscles that are lateral, your circle that's on the right side. Why is right of the right lateral? Because this is a right shoulder. Okay? The left of my left is also lateral. So it's the outside muscles, those are going to be my abs. The inside muscles are going to be my ads. The posterior muscles are going to be my extensors, right? Pulling in the direction of extension. And the shoulder allows transverse plane motion, right? Internal, external rotation, medial, lateral rotation. So that's when you look at the arrows that communicate spinning of the merry-go-round, right? So if this is a right, muscles that are trying to spin the merry-go-round this way are going to be internal rotators, and muscles that are trying to spin the merry-go-round the other way are external rotators. Once again, I'm going to say this before every circle we're about to explore. Even though you only have a right-sided reference to muscle function, you have a left-sided reference because you're going to have the same muscles on each side. So if you identify on the left that I need external rotators, you know that I need external rotators, for example, then you can still say, who are my external rotators by looking at a right-sided circle because those muscles are the same. Yes? You don't have to memorize two mirror circles. That actually makes things harder because this one, an external rotator spins this way, and this one, an external spins that way, right? So you still can reference right-sided circles to answer left-handed questions because you got the same stuff on the side. All right. The shoulder is separated. I like to separate it into country living and city living. You got country muscles. I've mentioned this before, right? You got country muscles. In other words, when you live out in the country, you can build your house as big as you want. You don't have to worry about neighbors getting in the way. So you can have some country muscles, And then you got some city muscles, some muscles that live inside the joint capsule and have to worry about things like not getting too big because of all the wiring it goes into. Okay? Remember we talked about how much wiring you have in your fingers? Well, guess what? Those wires got there because of passing through here. So all of those wires that you have to innervate very small little muscles have to pass through this, we call it a plexus, this big network of nerves that pass in your shoulder. And you have different vessels, plumbing that passes there too. So those city muscles can't get too big or they're going to occlude blood flow and occlude nerves. So what's our mechanism to keep muscles from taking up too much space? We either tendon the heck out of them or we limit their blood flow. We limit blood flow to some muscles on purpose. That's why if anybody ever notices, like if you tear maybe a country muscle, you rehab it and get it back. But if you tear a city muscle, a lot of times they have to go in there and fix it themselves because they don't have the same blood flow as country muscles. Because we're limiting their blood supply because we can't get them too hypertrophic. We can't get them too big. It's kind of cool. All right. Speaking of cool, it'd be nice if I could learn how to turn this thing on. I'm going to let the people decide. What is the first shoulder muscle you want me to talk about today? Is there a shoulder muscle that just keeps you up at night because you're just like, I can't stop thinking about it. I can't stop thinking about this muscle. It's just so cool. Anybody? Is there a shoulder muscle y'all want to start off with? The lat. That's my favorite muscle. We talked about this before class. Y'all, the lat is ridiculous. It's so cool. All right, first thing I'm going to do though, while the computer loads up, you see these 3 blue strips on the humerus here? So you're going to have these 3 blue strips. Those are the insertions of 3 big country-living muscles. Okay, and the way I was taught this in graduate school is the strip in the middle is a lady between 2 majors. So we're going to talk about the pectoralis major, the teres major, and the lady in the middle is the latissimus dorsi, lati, lati. So this right here is where your lat inserts. Now, notice this is anterior, right? This is in front. But the lat, as we know, comes from the back. So again, in terms of function, it's where do you cross? So watch this, how cool. Without even showing you on the screen, you're going to be able to know right away in terms of transverse plane function. If I have a muscle that comes posterior to anterior and pulls, what direction of rotation is that sucker going to want to cause? Internal rotate, absolutely. Latissimus dorsi has an internal rotate. It's kind of neat, huh? You know what else is an internal rotator? We're going to talk about the pectoralis major is an internal. You got a lot of internal rotators. You have a plethora of internal rotators, some big, powerful internal rotators, and you don't have a lot of external rotators. You know why? Because in terms of function, our ancestors, they had to make their hand move fast. So they put, it's not like they designed it, right? Okay? So whether you're talking about God, whether you're talking about evolution, you know what, it doesn't matter. We still get to the same place. You need more horsepower to make your hand speed up and then worry about slowing it down. Because if you had balance, you wouldn't make your hand go as fast. You put a lot of eggs into the speed up function because you have to make your hand go fast if you're throwing spears, throwing rocks, throwing slings. Okay? So we put a lot of eggs in our internal rotation basket because we're trying to speed up the hand to murder things with. Okay. Animals, critters. Or defend, right? To defend things. Rocks are useful. Can anybody confirm that I have these slides up on Moodle? I do or don't have the shoulder? Do not? Okay, I'll make sure to put it up right after class. Can someone lower the screen for me? Thank you, thank you, thank you. All right, guys, so check this out.
The latissimus dorsi.
I became infatuated with this muscle when I heard an ortho give a presentation at an athletic training conference. And his question was pretty straightforward, and it made everybody go like, oh, never thought of that. He's like, what is the most important skeletal muscle of sport, in your opinion? And people were throwing out dang near every muscle they could find. And he was like, oh, that's cool, that's interesting, yeah, that's important. He didn't disrespect all these other muscles people were throwing out. But he said, in my opinion, it's the latissimus dorsi. He said, look at the coverage area. This is a muscle that has origins on the pelvis, on the spine, passes through the scapula. It has scapular function because if you pull on the humerus, guess what also is going to get pulled on the scapula? Like in other words, if you're trying to stretch someone's scapula and you pull on the arm, their scapula is going to depress, right? So this muscle to get to the humerus crosses the scapula to get there. Oh, and by the way, it has tremendous shoulder function. So shoulder, scapula, trunk, pelvis, there's no skeletal muscle like it in the body. And although I'm not going to hold you accountable for this, I did talk about it a little bit. You just look at that son of a gun and you can see how it would help to twist the trunk. How it would help when you grab onto something and that lat is trying to do this at the trunk, this at the scapula, this at the shoulder. It's incredible. If I could get this muscle's autograph, I would probably get it for my personal collection. So the latissimus dorsi. Why do I call it a country muscle? Because it lives kind of outside the capsule. Inside the shoulder joint itself, like I said, a lot of wiring, a lot of plumbing, a lot of vessels. Outside, those muscles can hypertrophy and get big and not have to worry, they don't have to worry about occluding anything intrinsically inside, okay? I know darn well you guys have seen like some people's lats look like wings, right? It's because they're country muscles. There's room to roam, there's room to grow out in the country. Or another way you could look at it is, in the country there's room to develop, right? Like a new subdivision can develop in the country. Here's another way to look at it. Like UL, our university, is kind of landlocked, right? There's no room to really grow because everything around us already has development. So that's kind of another example that there's room to grow out in the country with these country muscles. So, shut up, Caleb. What's the function? The function of the lat is threefold. In the frontal plane, as you can tell, it's trying to pull the humerus in, right? Pulling in the direction of adduction. So, if this is my lati, has an adduction pull. Now, because it's coming posterior to anterior, it's also trying to pull to line these things up, right? Pulling in a direction of shoulder extension. Pulling in the direction of shoulder extension. And then the final one I told you guys is the transverse, right? Pulling in the direction of internal rotation. So in terms of shoulder function, the lat is a shoulder extensor, adductor, internal rotator. Because of the direction of pull. There's some midway function on this one I'm not going to hold you accountable for. But it should kind of make sense that when I pull in a direction of extension, once it lines up, what if I keep going up? It would make sense that eventually there's going to come a point in the range of motion where you kind of want to pull it down. So if your instinct is like, does that happen? The answer is yes. But in anatomical position, there's still some range of motion to line those things up. Okay? Latissimus dorsi, Padma, that is a big, powerful muscle. You think about the Olympic swimmers, right? They look like they have wings. Think about all the different things the lats do in the trunk and the pelvis and the shoulder and the scapula. This sucker gets used a lot. A lot, a lot, a lot, a lot, a lot. Okay? So remember, for the purposes of this class, I'm not holding you accountable to it has an origin on the pelvis, and it has an origin on the sacrum, and it has an origin on the... It's about how does it cross and how does it pull. In terms of the shoulder, in the sagittal plane, it's coming posterior to anterior, so it's like telling the humerus, get back here. In the frontal plane, it's like, get down here. Then in the transverse plane, it's spin here. Cool? Okay. Which one next? Give me a shoulder muscle. Deltoid. Oh, what a good one. Read my mind. Deltoid, triangular, right? Here is the important thing about the deltoid. It is one muscle. It's only one. What about the anterior? We say South Louisiana, right? There was one state of Louisiana. South Louisiana isn't a new state, it's just an area of a state. So when we say things like anterior deltoid, that's not a separate muscle, that's just a part of a fan-shaped concept. So talking about the deltoid helps me introduce you to a fan-shaped concept. Fan-shaped muscles are super unique. They're very versatile. With fan-shaped muscles, pecs are a fan-shaped muscle. When I get to the hip, I'm going to show you some different fan-shaped muscles. Fan-shaped muscles have at least one function that every fiber pulls in the same direction, but they have different functions in other directions. Fan-shaped muscles have the same, so if you imagine my hand forming a fan, all of my fingers technically have a down pull. Even the ones on the extreme have a little bit of component, but the ones on this side pull this way, and the ones on that side pull the other way. Why would muscles do that? Because we don't live in robot world, man. We have to have pull for every type of position we need to get our hands to. And what's really cool about muscle fiber distribution, when motor units branch into the fiber, they don't branch all over the place. They're very small in their window of branching. So what that means is that for a fan-shaped muscle like the deltoid, I can recruit motor units in the front that have the same lateral pull, but now all of a sudden have an anterior pull. Or I can recruit certain fibers in the back that have the same lateral pull, but have a different sagittal pull. And the same ones in the front also have a different transverse pull as the ones in the back. So the deltoid itself is actually one muscle. Now, here's where some miscommunication can come from. And I get it. It's especially people that aren't trained in this, I understand. What does it mean to say deltoids? What it really means is arms. If you say deltoids, it's right and left. Or what I think people misunderstand is that deltoids, anterior, posterior, middle, right? That's not what that means. Deltoids plural doesn't mean I have 3 deltoids on one side. I just have one. Okay? So what are the 3 areas? Well, just like again, North Louisiana, South Louisiana, Central Louisiana, you have an anterior part of the fan, but that is a part of the same muscle as the posterior part of the fan. And the one in the middle is middle. Bless you. I know sometimes that can be mistaken as medial, but if you think about it, bless you, medial and lateral are referenced to outside and inside. This can't be medial because this is my lateral part of the arm. Does that make sense? I can't have a medial on the lateral. Bless you. But I can have a middle, right? You got one piece of bread, other piece of bread, what's in the middle? So middle deltoid is the proper reference, not medial. Does that make sense? Okay? Yes, sir. Say that again?
The middle deltoid, would it also not be lateral? I mean, it's not medial, just because it's, would it also not be referred to as lateral?
I can call it cat-a-minu. You can call it whatever you want. For this class, we're going to call it the middle. It's It's all good. Do you understand what I'm saying? I'm saying there's nothing wrong with that, but for this class, we're just gonna say it's in the middle. It's in the middle. That's a great question. And again, it goes back to something I've said before, that some people refer to the LCL, the lateral collateral ligament, as like the fibula collateral ligament. It's the same thing, right? So all we have to really make sure is that we're all calling it the same thing, so that way we're all on the same page about what it is. So there's nothing wrong with referring to that, or someone says it, but we just have to make sure we know what to call it in here. It's a great question. Yo, I got hung up, man. They were saying about the tibial collateral and fibular collateral. I'm like, no, there's new stuff. And I was like, oh, no, wait, it's the same stuff. It's all good. It's all good. Okay? So, anterior, posterior. Now, what do they do, and how do we communicate it on our circle, guys? This is a little bit of a challenge. Okay? There's no such thing as perfect. All we can do is strive for optimal. So the first thing you may say is, Campbell, you're a hypocrite. You have the different pieces broken up, right? And so what I'm going to tell you is that I'm teaching you that it's this one muscle, but for function, we're breaking it up for the different parts in their function. If it helps you to understand this better, take your pencil and just connect the dots, almost like it's like a teeter-totter. So connect the squares to the middle. So that way you can be like, oh, it's one thing that's just really balanced, and I can really see the anterior part up in the front lateral and the posterior part in the back lateral. So it's whatever helps you to see it. But I can't put the whole muscle on the axis because the front part has different functions than the back part. So it's written that way for function. It's written that way for function. But on the test, I'm going to go fishing. I'm going to say how many muscles make up the right deltoid. And I'm fishing for people to tell me through. But it's one. Here's another example y'all are familiar with. Upper chest, right? Upper pec. Or upper pec, it's the same muscle. It's just a different part. It's a fan. And just like the upper pec is still a pec, it's just an area. It's the same concept. Same concept. Okay? So, on the test, if I ask you, what's the function of the left deltoid? The only thing that all of the fibers, look, let's look at some origins. So you see on this spine of the scapula, that's back origin. You see on this acromion, that's middle origin. And you see on this collarbone right here, that's anterior origin. There's something called the deltoid tuberosity that's midway through the shaft that it's tugging on. But the point is that it just comes in like a fan. All the fibers are pulling out. All the fibers pull laterally. So if I say, what's the function of the deltoid? That's me saying, what do all the fibers do together? All the fibers don't pull forward. All the fibers don't pull back. But all the fibers do pull out. Does that make sense? And again, this is in the anatomical position. So what's the function or functions of the entire deltoid? There's only one. The front part can do something different, and the back part can do something different as well, okay? So let's look at the anterior, the front part. Front part not only has a lateral pull, but it also has an anterior pull. So the anterior portion of the deltoid muscle, notice how I said that. The anterior fibers, the anterior portions, the anterior strings can not only pull laterally, but they can pull anterior. In addition, the vertical part pulls forward, but the transverse part can actually spin the same way the lat spins. It can be an internal or medial rotator. So if you think about the obliquity, remember we talked about obliques running at angles? So the obliquity of the anterior deltoid gives it an anterior pull. Basically, it's trying to bring the deltoid tuberosity, which is lateral, to the front part to line up. He doesn't feel it. Shoulder flexor, shoulder abductor, internal rotator. So if I say, what's the functions of the anterior part of the deltoid, It's a different question. The front part can pull forward, can pull out, and spin in. It's a certain part, right? Even though you have one muscle, different parts can do different things. Just as North Louisiana and South Louisiana. We can do different things. Some, in terms of accents and in terms of culture, there's some different cultures there, but we're still part of the same state. We are family. Posterior has the mirror opposite of the anterior in sagittal and transverse. They have the same in frontal, but they have opposites, sagittal and transverse. Right? The posterior is trying to bring the shoulder back, pulling in a direction of shoulder extension, and it's trying to spin that deltoid tuberosity to go line up laterally or externally. And actually, remember we talked about with the cervical, the canceling out stuff, right, left and right, sternocleidomastoid cancels out here, cancels out there, and works together. It's kind of the same thing. Anterior and posterior areas of your deltoid cancel out sagittally, cancel out transversely, and they can work synergistically when you just need that level. It's cool. Okay. So, to reiterate, if I ask you the function of the right deltoid, because the middle is like an oblique, the middle is like a rectus. Straight down in anatomical position, right? And then you have externals. I'm just trying to show you the similarities that we have here, right? So it's like you have your rectus, and then you have your obliques. It's kind of cool. Now that's an anatomical position. Some of you I love little hamsters, man. Some of you may be like, if it's straight down and anatomical, does it obliquate when I go away from anatomical? Yeah, heck yeah. Which again makes a lot of sense, because when I need internal rotators to slow down the external rotation, my middle delt could be like, I got you, I got some extra help pulling you back. And when I'm trying to slow down internal rotation, what a great gift to have some extra help slowing down my internal rotation with my posterior. So yes, it's a midway muscle. In anatomical position, it pulls straight laterally, but when you rotate, you give it spirality, you give it obliquity, and the opportunity to pull you back to anatomical position. That's really cool. That's really cool. Okay? So, on your circle, how many of you guys, you don't have to put it up, but if you're circle learners, this is really important that you see those three boxes and see them separately only for function. But you somehow connect them or make a note of them that those are just areas of one muscle. Does everybody understand that? What I don't want is, I don't want you to not understand that and then on the test put, there's 3 muscles in the deltoid. I only put it like that for function.
Whenever you were saying that the middle deltoid acts like the rectus and helps in the transverse plane.
It can. It just can't do it in anatomical.
Okay. It's only in the transverse plane. It's not frontal or sagittal or anything like that.
Yeah, it's transverse, because what happens is that when you do this or you do that, it's still kind of on the axis. So like if you think about a bilateral axis, front muscles can do this, posterior muscles. Well, if it's over the top, it's kind of like a patella. It's like the patella, when you flex your knee, runs right over the top. So it doesn't matter where your rotation is, because it only pulls over the top. It's only the direction of extension. You can't give it spirality to do anything else, because that rope lies right over the top. Yeah. What a great question. What a great question. So only worry about it in terms of transverse plane, giving itself obliquely. Okay? I promise you we're going to do more than just 2 muscles next class. But you know what's cool about those first 2 muscles? Those are kind of the more complex ones, man. There's a lot going on there. We're going to get into, we still have a few minutes. I'm not going to get into new muscles, but we're going to get into the city muscles. We're going to get into our rotator cuffs, that's city muscles, and show you why tearing a rotator cuff muscle more than likely needs a doctor to go in there and fix it up. blood flow. You can't afford, or how come those door rotator cuff muscles tend to get weak so easy? Blood flow. Blood flow. We have to limit hypertrophy because we can't have too much pressure inside of all our wiring and plumbing. It's all about blood flow, okay? All right, any other questions? What a great group you guys were today. All right, gotta go.